So we are looking at lecture 2A. 2 stands for the second lesson that we are covering, and A is the first lecture of the second lesson. So the lesson is angle and its measurement. Okay, so let's look at this lesson. Fine, you know how to draw the angle using a protractor. But using a protractor, you have drawn an angle from 0 degrees, which looks like this, where both the arms coincide in the same direction. Okay, like angle AOB, this is 0 degrees, and you have an angle like this, angle XO, say Q, which is of 180 degrees. So using a protractor, you can draw an angle from 0 degrees to 180 degrees. Okay, but we are going to look at some other angles now. First is directed angle. What is the first part? Directed angle. So let's understand what is directed angle. The ordered pair of rays OA bar and OB bar. You know that angle is made up of two rays which have the same starting point. Okay, those two rays are called arms of the angle. Okay, so ordered pair of rays OA bar and OB bar, okay, together with the rotation of the ray OA to the position of the ray OB is called the directed angle AOB. Okay, so suppose OA is the initial ray. OA is the initial ray and OB is its final position, and suppose the initial ray is rotated in the anticlockwise direction to reach the final position, then the angle is considered to be positive. And if OA bar is rotated in the clockwise direction to reach, say, OP bar, then this particular angle which we formed just now is called a negative angle. So this is a new concept, positive and negative angle. Okay, where OA is called the initial arm, OA is called the initial arm, and OP is called the terminal arm. Okay, fine. So that was as far as directed angle is concerned. Okay, we know that the point from where the two rays start is called the vertex. Okay, also suppose I have an angle AOB which is like this in the anti-clockwise direction, and I have another angle of equal measure AOP, equal measure but in clockwise direction, then angle AOB is not equal to angle AOP. Why? Because this is a positive angle and this is a negative angle. Okay, even though rotation is same, that is angle is same, the angle is not equal because one is positive, second is negative. Next is zero angle, we have seen that. Okay, now zero angle can also be considered as one rotation angle, and this is very important concept. Okay, like Suppose you have an angle like this, or you have a ray like this, OA, and you rotate it completely through 360 degrees, then that is equivalent to 0, but it is called as one rotation angle, which is 360. So whenever I say 360 degrees angle, it can be represented as 0 degree. Also, any multiple angle, any multiple of 360 will also be a 0 degree angle. Okay. So this is one complete rotation. Then you have a straight angle. Straight angle will be half of rotation. Okay. But if I consider angle AOB like this, then this will be positive. So it will be plus 180. And if I consider angle AOB like this, it will be negative. So it will be minus 180. But it will be a straight angle. Okay. Then you have a right angle. That is 1/4 of rotation. But there is a point over here to be noted. If I have AOB, then this is positive because it is in anti-clockwise direction and the angle is plus 90 degrees. Whereas if you consider angle AOB dash, this is negative and it is minus 90 degrees. Okay. So then you have angles in standard position. Okay. Now rectangular coordinate system. What is rectangular coordinate system? X and y axis. This is positive x, positive y, negative x, negative y. Okay. This is rectangular coordinate system. Rectangular coordinate system, which is also known as Cartesian coordinate system. Okay. A directed angle with its vertex at origin O and initial ray along positive x-axis is called angle in standard position. Okay. So you have one angle like this, say for example alpha, angle XOP. Then you have angle XOQ, for example beta. And then you have angle XOR. If measured like this, it will be say minus theta. And suppose I decide to measure that angle like this, XOR, then it will be plus, for example, phi. Okay. These are all angles in standard position where the vertex is at the origin and one arm, that is the starting arm, we can consider to be along the positive x-axis. Okay. Then angle in a quadrant. A directed angle in standard position is said to be in a particular quadrant if its terminal ray lies in that quadrant. For example, suppose to start with, let's consider what are quadrantal angles. So you have angle POQ. POQ is like this, 90 degrees. Okay, fine. Then maybe you have angle POS, which is like this, which is minus 90 degrees. Okay. Then you have, very interesting, pay attention. Then you have an angle like this as shown over here. Okay. This is 90, 90, 90 minus 270 degrees. Okay. So 90 degrees and minus 270 degrees are the same angles. Okay. Then maybe you have an angle like this, which is plus 180. Okay. Fine. Now, coterminal angles. What are coterminal angles? Directed angles of different amount of rotation having the same position of initial and terminal rays are called coterminal angles. So suppose the initial and terminal rays are same. For example, OA and OB as shown over here. Now I start from OA and I rotate like this. So when I reach A, I have rotated through 360 degrees and plus this 30 degrees. So angle AOB, when I measure like this, it is 390 degrees. Okay. Whereas angle AOB, when I measure like this, it is minus 330. Why it is minus 330? It is actually minus 330. Why it is minus 330? Because we are rotating in the clockwise direction. Also, one rotation is 360. Out of that, this 30 degree has gone. So this is minus 330 degrees. Okay. So these two angles, AOB, okay. So we have variety of angles over here. One angle is 30 degree, one angle is 390, one angle is minus 330. All these are called as coterminal angles. So you have to keep all these concepts with you, okay, and we will use them as and when required, okay. Measures of angles, fine. So you have the sexagesimal system, which is also known as degree measure, and you have the circular system, which is known as radian measure, okay, fine. So just like we have 1 meter and 1 centimeter, you have two units for measurement of length. These are units of length, okay. Similar to this, you have 1 degree and 1 radian. So now onwards, most of the angles will be measured in radians, okay, especially in calculus. But for the time being, we'll be using degree and we'll learn what is the conversion between degree and radian, okay. Now, what does he say? One rotation angle is divided into 360 equal parts. So you have one rotation angle like this, one rotation angle like this. This is 360 degrees, and that is divided into 360 equal parts, and 1 upon 360th of one rotation, 1 upon 360th of one rotation is 1 degree. Okay, 1 upon 360th of one rotation is 1 degree. Okay, then 1 upon 60th part of 1 degree is called 1 minute. So instead of saying like this, suppose we say that 60 minutes is 1 degree. 60 minutes is 1 degree. Okay, and 1 upon 60th part of a minute is called 1 second. So suppose I say 60 seconds is 1 minute. Now this particular concept is related to angle. It is not related to time. This is measurement of angle. Even though the words are similar, don't confuse it with measurement of time. Okay, fine. Then you have circular system, that is radian measure. Okay. In radian measure, the unit of measurement of angle is radian. Okay. Now, suppose there is a circle with radius r. R is the radius. Okay. And suppose that particular radius is rotated through some angle, say for example angle theta, to get an arc of length r. Okay, fine. Then in that case, this is arc, AB is the arc. Okay, in that case, the angle subtended at the center will be 1 radian. What is theta? Angle subtended at the center of circle of radius r by an arc of length r. Okay, so that is the concept of 1 radian. Okay, fine. So we will continue about radian in the next lecture. For the time being, we'll close this lecture. Okay.